You know those portals you see in sci-fi?
Hmm.
Stepping through a door to another world or another time. Always thought that was super cool. And get this. Today we're going to deep dive into this physics paper that kind of sort of says that might actually be possible. I mean, obviously it's all theoretical, but the science is really something.
Yeah, this paper is pretty wild. It basically says we've been thinking about gravity all wrong. Like, we always think of it as this force that pulls everything together, right? But they're saying it's actually a push.
A push. Okay, now I have to know more. How could gravity be a push?
So they call it the SMF RVS model. SMS is subtle magnetic field,
Mm-hmm.
and RVS is relative vacuum of space. Yeah, no, it's a lot.
Yeah, just a bit.
But picture this. The universe is like a giant bathtub, and it's full of water. That water is the RVS. And then everything in the universe, planets, stars, whatever, they're all floating in it. Now imagine that water has like tiny little magnets all throughout it. Those magnets are the SMF, and they create these like currents and eddies in the RVS.
So instead of the Earth pulling me down, I'm actually being pushed down by these tiny magnets in this space water.
Pretty much, yeah. And there's an equation for it, too, to calculate this push-based gravity. It looks super complicated, but basically it says the force of gravity depends on how strong those magnet currents are in the RVS, how far away you are from them, and this thing called the Fibonacci scaling factor.
The Fibonacci scaling factor, that sounds important.
It is. This is where it gets really interesting. So this paper says the universe isn't like a smooth, continuous flow of time. It's more like a bunch of snapshots, like frames in a film. Each snapshot is a different stage of the universe, a different level of detail. They call these stages fractal iterations.
Fractal iterations, like if you look at a coastline from space, and then you zoom in closer and see more details, like bays and inlets. And then zoom in even closer and you see individual rocks and grains of sand. Each zoom level is a fractal iteration, right?
Exactly. And just like those different zoom levels show different details of the coastline, each fractal iteration in the universe shows a different level of detail in, like, the fabric of reality. Now, this Fibonacci scaling factor, it changes with each iteration. It's like adjusting the focus on a microscope, bringing different parts of gravity into focus.
So as the universe zooms in through these iterations,
Yeah.
the strength of this push-based gravity could be changing.
Right. And they think the Fibonacci scaling might follow a pattern similar to the Fibonacci sequence, where each number is the sum of the two before it. This Fibonacci-like pattern could be like the key to how gravity works at these different levels of detail.
Okay, Fibonacci sequences, fractal iterations, gravity as a push. This is a lot to take in, but where do portals fit into all of this?
So the paper says that if we could like manipulate this Fibonacci scaling and amplify the effects of the SMF and the RVS, we might be able to create regions where gravity acts really, really weird. And one of those possibilities is that a portal could form.
Wait, are you saying we could actually make a portal? Like a real, actual portal?
It's a pretty big claim, and the paper says it's super speculative, but their theory is really detailed, like the math all checks out. To do it, they think we'd need to build this Fibonacci spiral mirror chamber.
A mirror chamber. Okay, now you got me hooked.
Picture this. You walk into this chamber, and it's completely enclosed by mirrors, all arranged in this Fibonacci spiral pattern.
Whoa. Sounds like walking into a kaleidoscope. But how would that create a portal?
So that's where it gets really interesting. Their model says that the spiral shape would amplify the SMF and RVS waves every time they bounce off a mirror, and the Fibonacci scaling ensures that this amplifies more and more with each fractal iteration. Basically, it could create a spot in the center of the chamber with insanely strong gravity, or even negative gravity.
Negative gravity, like things would fall up.
Yeah, it's hard to say for sure because we've never actually seen negative gravity. But some physicists think that negative gravity could be how you make a wormhole, like a shortcut through space and time.
So this chamber could create a wormhole. That's insane.
Right.
But wouldn't it be super hard to actually build something like that? Like impossible with what we have now?
Oh, for sure. It would be incredibly difficult. But the paper isn't about the how-to, it's about the theory of how the chamber would work. And that's still pretty amazing.
It's like a glimpse into the future,
Yeah.
where the impossible becomes possible. But before we get too carried away with portal fantasies, I think we should break down this whole Fibonacci spiral mirror chamber thing a little more. How does it actually amplify the SMF and RVS waves? And what's so special about the Fibonacci spiral anyway?
Great questions. The paper goes into all the details of the design and function. Let's start with the Fibonacci spiral itself. What do you think is so special about that shape?
Well, I remember from art history
Yeah.
that the Fibonacci spiral is everywhere in nature, right? Like seashells and sunflowers and stuff. It's this like perfect repeating pattern, almost like it has its own harmony, you know? Maybe that's what makes it so good at amplifying those waves.
Yeah, you're totally on the right track. The Fibonacci spiral isn't just pretty to look at. It has
Mm.
these really unique mathematical properties that make it perfect for this kind of thing. Like one thing, it's really good at packing things together. Think about how the seeds are arranged in a sunflower. They follow a Fibonacci spiral, and that lets them fit like the most seeds possible in a small space.
So are you saying the spiral shape of the chamber helps to like concentrate the SMF and RVS waves, pack them in tighter?
Exactly. The spiral creates all these different paths for the waves to bounce around like a pinball machine, and each bounce amplifies the wave a little bit. And since they're packed so close together, they all kind of resonate with each other.
Whoa, like a giant echo chamber for these space currents. But how does that tie back into the fractal iterations?
This is the really cool part. So the Fibonacci spiral, it's a fractal itself. The pattern repeats at different scales. Like if you zoom in on a small part of the spiral, it looks just like the big spiral. It mirrors that fractal nature of the universe from the paper.
So the chamber isn't just amplifying the waves, it's aligning them with how reality is actually structured.
Yep, that's the idea. It's like tuning a musical instrument to a specific frequency. By matching the chamber's shape to the fractal universe, you basically create a resonance chamber that maximizes the impact of those SMF and RVS waves.
Man, this is wild. So we've got these waves bouncing around in this perfectly tuned chamber, getting stronger and stronger with each bounce and each fractal iteration. Then what? How do we get from souped-up waves to an actual portal?
So the paper says that if the amplification is strong enough, the SMF and RVS interaction at the center of the chamber could actually, like, flip its sign. Remember how gravity is a push in this model? That push comes from the positive interaction between SMF and RVS.
Like all those tiny magnets in the space water are pushing in the same direction.
Exactly. But what if we could make those magnets repel each other? Make the SMF and RVS interaction negative?
Would that be negative gravity? Like
Sure.
stuff would fall up.
It's a weird idea. And the paper doesn't really say what negative gravity would actually do, but they compare it to negative energy densities in Einstein's theory of relativity.
And those negative energy densities are like
Yeah.
connected to wormholes and warp drives, right? The stuff that bends space and time and lets you travel faster than light.
Bingo. The paper says a negative SMF-RVS interaction could have similar effects, maybe creating a warp in space-time that acts like a portal.
Whoa, this is heavy stuff. But how realistic is any of this? Creating negative gravity, building this chamber with perfectly reflecting mirrors and a Fibonacci spiral? It all sounds so hard to do, like impossible.
Oh yeah, it'd be super challenging. The paper even says that there are huge technical challenges. For one, the mirrors would have to be insanely precise, reflecting almost all of the SMF and RVS waves. Like any energy lost would mess up the amplification.
Makes sense, like trying to build the perfect echo chamber where the sound just keeps bouncing forever. But with something as subtle as these SMF and RVS waves, wouldn't even a tiny flaw in the mirror cause problems?
Totally. And that's not the only problem. The waves themselves would need to be perfectly synced up, staying in phase as they bounce around. If they get out of sync, they could start canceling each other out.
So you don't just need perfect mirror, you need to like choreograph a perfectly synced wave symphony in the chamber. Sounds like a pretty big ask.
It would be a huge engineering feat. And then there's the safety question, too. Like, let's say we could actually build this thing. What happens when you turn it on? What if you actually create negative gravity? What happens to the people and things inside the chamber?
Yikes, that's a good point. We're talking about messing with the fabric of reality here. Who knows what could happen?
Exactly. And the paper doesn't really talk about that at all. It's focused on the theory, not on how to actually build it or the risks involved.
So it's a really cool thought experiment,
Yeah.
but maybe one that's best left as a thought experiment for now. But I do have to give them props for even thinking of this. It reminds us that even the craziest ideas can lead to amazing discoveries.
I agree. Even if we never build this chamber, this idea of push-based gravity and fractal scaling could inspire all sorts of new research, maybe even breakthroughs in other areas of physics. It shows that science is about pushing the boundaries and exploring the unknown, even if it seems impossible.
Well said. But before we wrap up this deep dive, I think we should give our listeners the key takeaways.
Yeah.
What are the most important things to remember about this model of gravity and this Fibonacci spiral mirror chamber thing?
Sure, let's go back to the basics. Okay, so the big thing is this paper, it basically throws out how we usually think about gravity. Instead of a pull, it's a push from these subtle magnetic fields in the relative vacuum of space.
Right, the SMF and RVS,
Yeah.
those tiny magnets in the space water. And then there's that Fibonacci scaling factor, which changes how those courses work at different scales in the universe, the fractal iterations.
Exactly. And the paper says if we built this Fibonacci spiral mirror chamber, we might be able to make those forces super strong or even negative,
Yeah.
which, yeah, could be pretty mind-blowing.
Wormholes, other dimensions, maybe even time travel, right? But building that chamber, it sounds crazy hard.
Yeah, for sure. The engineering would be insane. Perfect mirrors, perfectly synced waves.
Yeah.
That's way beyond what we can do right now. And then there's the whole safety thing, too. Like, what happens if you actually create negative gravity?
Right. Messing with reality like that, probably not a good idea.
Probably not.
So it's cool to think about, but maybe best left as like a thought experiment. Still got to admire them for even coming up with this idea. Shows how even crazy ideas can lead to breakthroughs, you know?
Totally. Even if we never build this thing, this push-based gravity idea and the fractal scaling, that could spark all sorts of new research. Maybe even lead to discoveries in other areas of physics. Science is all about pushing those boundaries, seeing what's possible.
Absolutely. Speaking of impossible, there's this one last thing from the paper. They said, even if we never make a portal, this research might lead to other crazy tech.
Yeah, they mention like using SMF and RVS to make anti-gravity fields. That would change everything, transportation, how we build things.
Whoa, imagine controlling gravity, making things float, changing which way is down.
Sounds like sci-fi, right?
Totally.
But who knows, maybe someday, thanks to this research, it won't be sci-fi anymore.
That's crazy to think. This paper about portals might also change things in ways we haven't even thought of yet. It really shows how everything's connected in science. One idea can lead to so many discoveries, change how we see the universe, open up possibilities we never imagined.
That's the beauty of it, right? It's all about discovery, about figuring out how the universe works, even if it takes us to these crazy, impossible-seeming places.
Definitely. So I think we've given our listeners a lot to think about today, from how we thought gravity worked to this whole push-based universe, this Fibonacci spiral mirror chamber. Even the idea of stepping through a portal. Maybe we're a long way off from doing those things, but it's those impossible dreams that push science forward.
Couldn't have said it better myself. So to everyone listening, keep asking questions, keep exploring, keep dreaming. You never know what amazing things are out there waiting to be discovered.
Thanks for joining us on this deep dive into the world of theoretical physics. And until next time, keep looking up and wondering.